December 19th, 2025. Remember that date, because in just a few weeks, humanity might witness the most important astronomical observation in our history. An object designated 3I Atlas is racing toward its closest approach to Earth, and what we discover on that day could fundamentally change our understanding of whether we're alone in the universe. But here's what NASA isn't telling you. The images that could have already answered our biggest questions, images taken by the HiRISE camera aboard the Mars Reconnaissance Orbiter on October 2nd, are sitting on a server somewhere, hidden from public view, not because of some conspiracy, but because of something even more frustrating: bureaucratic incompetence during a government shutdown that began October 1st, 2025. Right now, as you're watching this, 3I Atlas is hurtling through space at 61 kilometers per second. That's 210,000 kilometers per hour. It's carrying secrets from a star system that died before Earth was even born. And it's doing something that violates the fundamental laws of physics as we understand them. Let me be absolutely clear about what we're dealing with here. This isn't just another comet. This is an object that turned intensely, impossibly blue, bluer than our sun itself, while it was hidden behind our star during perihelion. For an object that should be 20 times colder than the solar surface to emit more blue light than our star is a direct violation of thermodynamics. This isn't a theory or speculation. This is what multiple independent instruments recorded. StereoA's twin cameras, the HI-1 and COR-2 instruments, both captured it. SOHO's LASCO C3 coronagraph independently confirmed it. GOES-19, a weather satellite monitoring solar activity, saw the exact same impossible blue glow. These are instruments designed by different teams, operated by different agencies, processing data through completely different pipelines. They all saw the same thing, and what they saw shouldn't exist. Dr. Avi Loeb from Harvard, and let me remind you, this is the former chair of Harvard's astronomy department, not some fringe scientist, has stated bluntly, "For this object to appear bluer than our star defies basic thermodynamics of how cold bodies interact with stellar radiation." He's not mincing words. He's telling us that what we're seeing is impossible according to our current understanding of physics. StereoA's twin cameras, the HI-1 and COR-2 instruments, both captured it. SOHO's LASCO C3 coronagraph independently confirmed it. GOES-19, a weather satellite monitoring solar activity, saw the exact same impossible blue glow. These are instruments designed by different teams, operated by different agencies, processing data through completely different pipelines. They all saw the same thing, and what they saw shouldn't exist. Dr. Avi Loeb from Harvard, and let me remind you, this is the former chair of Harvard's astronomy department, not some fringe scientist, has stated bluntly, "For this object to appear bluer than our star defies basic thermodynamics of how cold bodies interact with stellar radiation." He's not mincing words. He's telling us that what we're seeing is impossible according to our current understanding of physics. But the blue color is just the beginning. David Farnocchia from NASA's Jet Propulsion Laboratory, a navigation engineer with a PhD in mathematics from the University of Pisa, detected something even more troubling. During perihelion, 3I Atlas experienced non-gravitational acceleration of 135 kilometers per day, squared of radial thrust away from our star, plus 60 kilometers per day, squared perpendicular to the solar direction. Now let me explain why this is keeping physicists awake at night. For a comet to accelerate like that through normal outgassing, ice turning to gas and pushing the comet like tiny rocket engines, it would need to lose approximately 10% of its total mass over the course of a month, We're talking about billions of tons of material that should be creating a massive, bright, absolutely unmistakable cloud around the nucleus. Loeb's prediction was crystal clear. We should see a dense gas cloud around it in November and December. Not might see, not maybe we'll see, should see. Because the laws of physics, specifically conservation of momentum, require that this cloud exist. It's not optional. But here's the thing that's making everyone nervous. As our most powerful telescopes scan the space around 3I Atlas right now, they're not finding that cloud. The debris that physics says must be there isn't there. Let me take you back to how this all started, because the story of 3I Atlas reads like science fiction, except every word is documented fact. Loeb's prediction was crystal clear. We should see a dense gas cloud around it in November and December. Not might see, not maybe we'll see, should see. Because the laws of physics, specifically conservation of momentum, require that this cloud exist. It's not optional. But here's the thing that's making everyone nervous. As our most powerful telescopes scan the space around 3I Atlas right now, they're not finding that cloud. The debris that physics says must be there isn't there. Let me take you back to how this all started, because the story of 3I Atlas reads like science fiction, except every word is documented fact. But from the moment of discovery, 3I Atlas began revealing properties that defied all expectations. Let me walk you through the 9 documented anomalies, because when you see them all together, the picture that emerges is genuinely disturbing. The first anomaly is the orbital alignment. 3I Atlas's trajectory is aligned with our solar system's ecliptic plane, the flat disk where all our planets orbit, with a precision of only 5 degrees. For an object coming from a random direction in interstellar space, the probability of this is only 0.2%. It's as if 3I Atlas deliberately chose the most efficient route to visit multiple planets in a single pass. The second anomaly shattered our understanding of cometary chemistry. When large ground-based telescopes analyzed 3I Atlas's spectroscopic composition, they found something deeply disturbing. The object was emitting nickel, but without iron. In nature, nickel and iron are absolutely inseparable. They form together in the cores of massive stars, travel together through space, condense together in planets and comets. The only known exception occurs in industrial nickel refining processes, specifically the carbonyl process developed in the 19th century. And guess what the dominant gas being emitted by 3I Atlas is? Carbon monoxide. 87% of all observed volatile emissions, the exact gas used in industrial nickel refining. The third anomaly involves the color sequence. In July, it appeared red, normal for a distant comet with dust dominating. In September, it turned green, which could be explained by C2 emissions, except 3I Atlas has extraordinarily low levels of carbon chain molecules. Then in October came the impossible blue that violates fundamental thermodynamics. The fourth anomaly is the acceleration rate. 3I Atlas brightened at a rate that broke all predictive models. Every algorithm we used to predict cometary behavior failed. It's as if the object was following its own rules, ignoring the patterns we've observed in hundreds of comets over decades. The fifth anomaly is the sheer size. With a nucleus between 440 meters and 5.6 kilometers, 3I Atlas is much larger than typical interstellar visitors. Combined with its extreme velocity, the probability of finding an object that's both this massive and this fast is less than 0.1%. The sixth anomaly involves early activity. We detected outgassing beyond Jupiter's orbit, where it should have been completely inactive. The temperatures at that distance are so low that no known cometary ices should sublimate. Yet 3I Atlas was already active, already releasing gases, already defying our models. The seventh anomaly is the solar anti-tail. For a period in July and August, 3I Atlas produced a tail pointing toward our sun, the exact opposite of what physics says should happen. Solar radiation pressure always pushes material away from the sun, always. This is such a fundamental principle that finding an exception is like finding water flowing uphill. The eighth anomaly might be the most intriguing. 3I Atlas came from a direction that coincides within just 9 degrees of the origin of the WOW signal, that mysterious radio transmission detected in 1977 that remains unexplained to this day. The probability of this alignment happening by chance is 0.6%. The ninth anomaly is the impossible blue color during perihelion that I mentioned earlier. An object 20 times colder than the solar surface, emitting more blue light than the sun itself. This isn't just unusual, it's a direct violation of the laws of thermodynamics. And now we're potentially facing the 10th anomaly, acceleration without mass loss. If December 19th arrives and we still can't find the debris cloud that should be there, we'll be forced to confront the possibility that 3I Atlas is accelerating through some mechanism we don't understand. Dr. Loeb isn't pulling any punches about what this means. In his appearance on the Joe Rogan Experience, in his written statements, in interviews with multiple news outlets, he's been absolutely clear. When you have 9 documented anomalies in the same object, when the cumulative probability of all these anomalies occurring naturally drops below a certain threshold, you have a scientific obligation to consider alternatives, even uncomfortable alternatives, even alternatives that sound like science fiction. But not everyone agrees. Brian Cox, the physicist and science communicator, has stated his position unequivocally. Atlas is a comet made of carbon dioxide and water ices and bits of other things. It has a predictable orbit. It will pass by our star and continue drifting through the galaxy. He calls speculation about alien origins nonsense and sensationalism. Loeb's response was sharp and direct. Cox is like a cave dweller who finds a telephone and calls it just a rock. Real scientists play on the field, guided by data, while commentators sit on the sidelines repeating popularity contests. This scientific civil war goes beyond just these two scientists. It's a fundamental battle about how science should respond to anomalies, how much weight to give unlikely explanations, and whether the possibility of discovering something truly revolutionary justifies the reputational risk of being spectacularly wrong. But while scientists debate, the evidence keeps mounting, and some of that evidence is locked away where we can't see it. Let me tell you about the images that disappeared. On October 2nd, 2025, 3I Atlas passed just 30 million kilometers from Mars, closer than Mars has ever come to Earth in recorded history. The high-rise camera aboard NASA's Mars Reconnaissance Orbiter was perfectly positioned to capture the highest resolution images ever taken of this object. This is a camera that can resolve 30-centimeter features from 300 kilometers above the Martian surface. When pointed at 3I Atlas, it could achieve a resolution 3 times better than our best images from Hubble or Keck. Multiple researchers have confirmed that HiRISE was tasked with observing 3I Atlas during this window. The geometry was favorable, the pointing was possible, the observation was successfully executed, and then the images vanished into a bureaucratic black hole. The US government shutdown that began October 1st meant that while the observations were made, the data pipeline ground to a halt. Non-essential personnel were furloughed, communications stopped, data sharing slowed to a crawl. These potentially game-changing images are sitting on a server somewhere, unseen by the scientists who desperately need them. Loeb has been explicit about his attempts to access these images. He contacted the high-rise principal investigator directly, no response. He followed up, still nothing. NASA hasn't confirmed or denied the existence of these images. They've said absolutely nothing. The silence is deafening. Loeb calls it terrestrial stupidity, not evidence of aliens, not a cover-up, but basic human incompetence interfering with potentially the most important discovery in human history. The universe doesn't care about government shutdowns, he said. Science doesn't pause because politicians can't agree on spending bills. But there's another frustration that's even worse. The JUICE probe, the Jupiter Icy Moons Explorer, made detailed observations of 3I Atlas between November 2nd and 25th, 2025. Multiple instruments, cameras, spectrometers, particle sensors, all perfectly positioned to observe the comet in the immediate aftermath of perihelion, during the critical window when any massive outgassing should still be visible. JUICE has already seen what we're desperately waiting to discover. The data has been collected. The observations are complete. But we won't know what they show until February 2026. The reason is purely technical but maddening. JUICE is currently about 2 astronomical units from Earth. At that distance, with its medium-gain antenna, the data transmission rate is painfully slow. The information that could answer our biggest questions is sitting in a computer memory aboard a spacecraft, traveling through space at the speed of light, but still months away from reaching us. This is the reality of space exploration. Even when we have the answers, sometimes we have to wait for them to travel hundreds of millions of kilometers to reach us. As December 19th approaches, the entire scientific community is mobilizing. This will be 3I Atlas's closest approach to Earth, 270 million kilometers. Still far by everyday standards, but close enough for our best telescopes to see details we've only dreamed about. Hubble, Webb, and dozens of ground-based telescopes will all turn their full attention to this visitor from beyond. We'll finally get the high-resolution data we need. We'll see the true color with spectroscopic precision. We'll measure the spectral lines and identify exactly which molecules are present and in what proportions. Most importantly, we'll search for that missing debris cloud. If we find it, then perhaps 3I Atlas is just an extremely unusual natural object that's pushed our understanding to its limits, but ultimately fits within the framework of known physics. But if we don't find it, if this object continues to accelerate without any visible mass loss, then we're facing something that operates outside our understanding of natural celestial mechanics. The implications are staggering. If even one of these anomalies proves to be non-natural, we're looking at evidence that we're not alone in the universe. That technology from other civilizations is within reach of our telescopes, visiting our solar system exactly during the few decades when we've developed the ability to detect it. But even if 3I Atlas turns out to be natural, it's already revolutionary. The carbon dioxide dominance alone is rewriting our understanding of how comets can form. It's showing us that other solar systems can have fundamentally different chemistry, different building blocks, different rules. Every planet that forms in such a system would be alien in ways we've never imagined. The nickel without iron remains one of the most puzzling aspects. In billions of years of cosmic evolution, through supernovae and stellar winds and planetary formation, nickel and iron always travel together. They're forged in the same stellar furnaces, condensed from the same nebula clouds, locked together in the same crystalline structures. Finding nickel without iron in a natural object is like finding a forest where all the trees are missing their roots. The only processes we know that can separate nickel from iron are industrial. The carbonyl process, specifically, uses carbon monoxide gas at specific temperatures and pressures to extract pure nickel. It's a technique we developed for manufacturing, not something that happens in nature. Yet 3I Atlas shows exactly this signature: nickel without iron, accompanied by massive amounts of carbon monoxide. Some scientists have proposed exotic natural explanations. Perhaps in the extreme environment near a dying star, with exactly the right temperature and pressure conditions, nature could replicate our industrial processes. Perhaps during planetary collisions, the shock waves and heat could create temporary conditions that separate these elements. But each explanation requires such specific, unlikely circumstances that they strain credibility. The timing of 3I Atlas's passage through our solar system adds another layer to the mystery. It arrived at exactly the right moment to pass close to Mars, Venus, and Jupiter. It became invisible from Earth during perihelion, hidden behind the Sun, at the very moment when the most dramatic changes were occurring. The probability of all these alignments happening by chance is 0.005%. That's 5 in 100,000. If you were designing a trajectory to survey our solar system while avoiding detailed observation during a critical phase, you couldn't do much better than 3I Atlas's path. It's passing close enough to our major planets to what? Observe them? Sample their atmospheres? We don't know. We can only note that the trajectory seems almost too perfect to be accidental. The extreme velocity, 61 kilometers per second, tells us something important about this object's origin. It's moving so fast that it must have received a massive gravitational boost at some point. Perhaps it passed close to a giant star or was ejected from a binary system. Or perhaps, and this is where we enter speculation territory, it was deliberately accelerated to this speed. At 61 kilometers per second, 3I Atlas could traverse the entire galaxy in just 450 million years. If you wanted to send probes to survey multiple star systems, this is exactly the kind of velocity you'd want. Fast enough to cover vast distances in reasonable time frames, but slow enough to make useful observations as you pass through each system. The early activity beyond Jupiter's orbit defies our understanding of cometary physics. At that distance from the Sun, the temperature is about minus 170 degrees Celsius. No known cometary ices should sublimate at those temperatures. Water ice is frozen solid, carbon dioxide ice is stable. Methane, ammonia, carbon monoxide, all the usual suspects are locked in their solid state. Yet 3I Atlas was already active, already releasing gas, already creating a visible coma. Either it contains exotic ices we've never encountered, substances that sublimate at incredibly low temperatures, or something else was causing the activity. An internal heat source? A chemical reaction triggered by our sun's magnetic field? We simply don't know. The anti-tail phenomenon remains completely unexplained. For a brief period, 3I Atlas produced a jet of material aimed directly at our sun. This violates one of the most basic principles of cometary physics. It's like watching smoke from a fire flow toward the flames instead of away from them. Multiple teams have reviewed the data, checked for errors, run simulations. The conclusion remains the same. For those weeks in July and August, 3I Atlas defied the laws of physics as we understand them. The material was definitely moving toward the sun. The observations are unambiguous. One hypothesis is that 3I Atlas was releasing material from its far side, the side facing away from the sun, which then curved around due to complex electromagnetic interactions. But the models don't support this. Another idea is that we're seeing some kind of optical illusion caused by the geometry of observation. But multiple telescopes from different locations all saw the same thing. The connection to the WOW signal location is either an incredible coincidence or a clue to something larger. The WOW signal, detected on August 15, 1977, remains the strongest candidate for an extraterrestrial radio transmission ever recorded. It came from the direction of the constellation Sagittarius, lasted 72 seconds, and has never been explained despite decades of investigation. 3I Atlas's trajectory, when traced back billions of years, passes within 9 degrees of where the WOW signal originated. In the vastness of space, that's remarkably close. If both the signal and the object came from the same source, it would suggest a civilization that was active billions of years ago, perhaps sending both radio messages and physical probes across the galaxy. Of course, this could all be coincidence. Space is vast, and given enough objects and signals, some will appear to align by pure chance. But when you add this alignment to the other anomalies, the picture becomes harder to dismiss. The polarization anomaly is particularly interesting to physicists. Light waves oscillate in different directions, and when they reflect off surfaces, they tend to become polarized, aligned in certain directions. Different materials create different polarization patterns. It's like a fingerprint that tells us what something is made of. 3I Atlas shows extreme negative polarization that's never been observed in any other comet. The light reflecting off its surface is twisted in ways that known materials simply cannot achieve. Either we're looking at exotic materials created under conditions we've never encountered, or the surface has been engineered at the molecular level to produce these specific optical properties. Some scientists have suggested that billions of years of cosmic ray bombardment could have created unique surface structures, perhaps carbon nanotubes or other exotic arrangements of atoms. Others wonder if we're seeing metamaterials, artificially structured surfaces designed to manipulate light in specific ways. As we count down to December 19th, every telescope on Earth is being prepared, software is being updated, observation schedules are being coordinated. The entire planet is preparing to focus on a single point in space, hoping to answer questions that have plagued us since we first looked up at the stars. Will we find the missing debris cloud? Will new anomalies emerge? Will we finally understand what 3I Atlas is? Or will it leave us with even more questions, departing our solar system as mysteriously as it arrived? The scientific method demands that we follow the evidence wherever it leads. We can't ignore data because it makes us uncomfortable. We can't dismiss observations because they challenge our worldview. If 3I Atlas is showing us something new, whether it's exotic natural phenomena or something else entirely, we have an obligation to investigate with open minds and rigorous methodology. This is potentially the most important moment in human history. We might be on the verge of discovering that we're not alone in the universe, or we might be about to learn that nature is far stranger and more varied than we ever imagined. Either outcome would be revolutionary. The carbon dioxide dominance alone is forcing us to reconsider everything we thought we knew about planetary formation. If comets in other systems are fundamentally different from ours, then planets forming in those systems would be alien in ways we've never considered. Their atmospheres would be different. Their chemistry would be different. The potential for life, at least life as we know it, would be radically different. Imagine a planet bombarded by carbon dioxide-rich comets like 3I Atlas, instead of water-rich comets like ours. Instead of oceans of liquid water, you might have lakes of liquid carbon dioxide under high pressure. The atmosphere would be dense with greenhouse gases from the beginning. Any form of chemistry, any potential for biology, would follow completely different pathways. This isn't just academic speculation. As we search for life in the universe, we need to understand what's possible. 3I Atlas is showing us that our assumptions about what makes a planet habitable might be far too narrow. We've been looking for Earth-like worlds, but perhaps life could arise in conditions we've never imagined. The preservation of volatile ices after billions of years of interstellar travel is remarkable. Cosmic rays should have destroyed most organic molecules. Impacts from interstellar dust should have eroded the surface. Close encounters with other stars should have boiled away the volatiles. Yet 3I Atlas arrives in our solar system still active, still outgassing, still revealing its secrets. This suggests either extraordinary luck or some form of protection we don't understand. Perhaps the object has a much thicker crust than we thought, shielding the interior from radiation. Perhaps it spent most of its journey in the cold depths between galaxies, where cosmic ray flux is lower. Or perhaps, and this is pure speculation, it was designed to survive such a journey. The fact that we're detecting interstellar objects at all is statistically surprising. Space is vast and empty. The chances of a random object from another star system passing close enough to Earth for us to detect should be infinitesimally small. Yet we've now found 3 in just a few years. This suggests that interstellar space is far more crowded than we thought. Current estimates suggest there could be trillions of such objects passing through our galaxy at any given moment. Each one is a messenger from another star system, carrying information about conditions we'll never be able to study directly. If this is true, it changes our entire perspective on the galaxy. Instead of isolated star systems, separated by vast empty voids, we're looking at a galaxy where material is constantly being exchanged between stars. Comets, asteroids, perhaps even more exotic objects, all wandering between systems, carrying chemistry and perhaps even biology from one star to another. The implications for panspermia, the idea that life could spread between star systems, are profound. If objects like 3I Atlas are common, then material from one system could seed another with organic molecules or even microorganisms. Life might not arise independently on each planet, but could spread like seeds on the cosmic wind. As December 19th approaches, we're not just preparing our telescopes, we're preparing ourselves for whatever truth 3I Atlas reveals. Whether it's natural or artificial, expected or impossible, we'll face it with the tools of science and the courage to accept what we find. The mystery of 3I Atlas reminds us that we're still in the early days of understanding our universe. Every generation thinks they have things figured out, only to be surprised by new discoveries that overturn established wisdom. 3I Atlas might be our generation's surprise, the discovery that forces us to rewrite the textbooks. In a few weeks, we'll know more. The close approach will provide data we've been desperately waiting for. Every major observatory will be watching. Every sensor will be recording. The entire scientific community will be holding its breath. Will December 19th change everything? Will it confirm that we're not alone? Will it reveal new physics we've never imagined? Or will it deepen the mystery even further? Whatever happens, we're living through a remarkable moment in human history. We're watching in real time as our understanding of the universe evolves. We're seeing science at its best, confronting the unknown with curiosity, courage, and rigorous methodology. The universe has sent us a messenger, wrapped in ice and mystery, carrying secrets from a star that died before Earth was born. On December 19th, we'll have our best chance to decode its message. Whether that message is written in the language of exotic chemistry or something else entirely, it's already changed how we see our place in the cosmos. We're not alone in receiving these cosmic visitors. They've been passing through our solar system for billions of years, long before humans evolved to observe them. But now, at this unique moment in history, we have the tools to detect them, study them, and perhaps understand them. 3I Atlas is more than just a comet or an anomaly. It's a reminder that the universe is vast, mysterious, and full of surprises. It's proof that no matter how much we learn, there's always more to discover. and it's evidence that sometimes the universe sends us exactly what we need to push our understanding forward. December 19th is coming. The truth, whatever it may be, is racing toward us at 61 kilometers per second, and when it arrives, we'll be ready. Check out the suggested videos on your screen for more incredible space discoveries and cosmic mysteries. The universe is speaking to us through messengers like 3i Atlas. We just need to learn how to listen.